Hello students, so in our last lecture we discussed Doppler effect and what is the formula for Doppler effect. F nu L, FL or nu L is equal to V plus VL upon V plus VS into Fs. Okay, V plus VL upon V plus VS into Fs. FL is known as frequency listened by listener, or it is known as apparent frequency, and Fs is a frequency of source or real frequency. So then we discuss the Doppler effect when source is moving on a circular road and listener is moving on a circular road. So now we discuss the question, students. See, so see one question. A whistle emitting a sound of frequency 440 Hz. Chalo. So here source is what? Whistle. A whistle emitting a sound of frequency. What is the frequency of source? 440 Hz. A whistle emitting a sound of frequency 440 Hz is tied to a string of 1.5 meter length. So see students, suppose this is the string and this is the whistle. A whistle emitting a sound of frequency 440 Hz. What is the frequency of source? What is the frequency? 440 Hz, and this is the whistle. Whistle is what? Source. Is tied to a string of 1.5 meter length. What is the length of string? 1.5 meter. Chalo. Now what? Then and rotated with an angular velocity of 20 meter per second. What is its angular velocity? Rotated with an angular velocity of 20 radian per second in a horizontal plane. Done, students. Moving in a circular, moving with an angular velocity of 20 meter per second in a horizontal plane. So moving like that. Okay. So and this is here we consider what at the now we want to find the range of frequency heard by an observer. Observer means listener. So we want to find what? Range of frequency range of frequency heard by an observer. Range of frequency heard by an observer. Chalo. So observer is stationary, students. Its speed is 0. Now we consider 4 different cases. Okay, 4 points. We want to find range of frequency, and range of frequency means we want to find maximum and minimum frequency. So we consider 2 points. Suppose this is the A. At A, what is the direction of velocity? In the direction of tangent. This is the B, this is the point C, this is the point D. So we consider the 4 different points A, B, C and D. Okay, we consider the 4 different points A, B and C, D. Chalo, so at A and C no Doppler effects are there, because as we know this is the listener, then source is moving in that direction, to away from that, away to towards the observer, away from the observer. But in that case, at point A and C, it is in the direction of vertical, so no Doppler effect is there. So at A and C, no Doppler effect is there. Now we consider first D point, and what is the speed of sound? That is 330 meter per second. Now suppose we first consider D point. So VL is 0 students, and see at a D speed is at D, what is the speed? Is in the direction from L to S. At point D, what is the direction of speed? L to S, and L to S is positive. So we consider now, but see how to find speed, students. See, it is the positive speed, but see, angular velocity is given and length is given. So length is equal to radius. So from the angular velocity, how to find linear velocity? V is equals to omega r. Okay, V is equals to what? Omega r. And why we took positive? Because see, at point D, this is the direction of tangent, so this is the direction of velocity, and it is from L to S. So at point D, velocity is positive, and what is that velocity? Omega r. Omega 20 at 1.5, so this is what? 30. Sure, but positive 30. Now what is the formula? FL is equal to V plus VL, V plus VS. Now what is the speed of sound? Speed of sound is 330. Listener is stationary. 330 plus 60. What is the frequency of source? 440. 330 by 360. Chalo, so what is our answer? That is 403. What is our answer? 403.3 hertz. Chalo, now we consider point C. Now we consider point C. Chalo, now we consider the point C. Okay, chalo, so sorry, point B. So see students, again VL 0. Now at point B, what is the direction of velocity? See, this is the direction of velocity, so it is from S to L. It is from S to L. So S to L means source to listener, so we consider negative. So now what is the answer? Speed of sound is 330, speed of listener 0. 330, what is that? Minus 30, because it is from S to L. At point B, S to L. So 330 by 300. 1 0 cancel, 1 0 cancel, 11 into 44, so 484. So see students, this is the range of frequency. 484 is a maximum frequency and this is the minimum frequency. Okay, so this is the example of circular motion of source. Now next question students. Next question is from the textbook. Textbook question number 25. Okay, next is a question 25 from the textbook. See students, this question is very important. This is the question of a type when sound is reflected back. Okay, suppose આપણે કારમાં જતા હોય, સામે મોટો એક માઉન્ટેન હોય, ત્યાં તો બહુ વોલ હોય મોટી, સો તમે હોર્ન પ્રેસ કરો એટલે શું થાય, પાછું જે તમારું હોર્ન હોય એ આફ્ટર સમ ટાઈમ તમને સંભળાય, યા તો તમે બોલો તો આફ્ટર રિફ્લેક્ટ ઇકો પાછો તમને સંભળાય. સો આ ટાઈપના ક્વેશ્ચન આવે છે. ચલો ધ્યાન રાખીએ. સી ધીસ ઇઝ ધ ક્વેશ્ચન 25 ફ્રોમ ધ ટેક્સ્ટ બુક. ઓકે, two questions છે 25 and 27. So first we see question 25. Now in a submarine, sonar is placed and this sonar emits sound of frequency 40 kilohertz. Suppose this is the sonar. Now this sonar is a source. Okay, so now that sonar is a source and what is that frequency? 40 kilohertz. Now see, now one enemy submarine moving towards sonar, means that this sonar is placed on a one submarine. Now enemy submarine is moving towards sonar. So enemy submarine is moving towards sonar and now it is a what? Enemy submarine is listener. Sonar is source, enemy submarine is listener, and enemy submarine is moving towards sonar with the speed of 360 km per hour. So what is the speed of listener? 360 km per hour. So students, convert it into meter per second. So 360 into 5 by 18. So what is the speed of listener? 100 meter per second. Okay, what is the speed of listener? 100 meter per second. So we want to find frequency of reflected sound from sonar. Find frequency of reflected sound by sonar submarine. And what is the speed of sound wave in water? So see students, in the first case, what is the first case? In the first case, there are the two case students. So in the first case, sonar is placed in a one submarine, and that submarine is stationary, so speed of source is 0. Speed of sonar submarine is 0. So in the first case, sonar is placed in a one submarine, and that submarine is stationary, and it emit a frequency of emit a sound of frequency 40 kilohertz. Now suppose this is the sonar, this is the sonar. Now this is the enemy submarine. This enemy submarine is moving towards the sonar. So first, that enemy submarine is listener. Then in the second case, this enemy submarine reflects some sound. Now enemy submarine reflects some sound. So after that, sonar becomes listener and enemy submarine becomes source, because now enemy submarine reflects some sound. So in the second case, enemy submarine reflects some sound. So enemy submarine is source and sonar is listener. તમે જતા હોય સ્ટુડન્ટ્સ, બહુ સામે તમારી સામે હાઈ વોલ આવી જાય, કારમાં છો તમે તો તમે હોર્ન પ્રેસ કરો છો, તો પહેલાં તમે શું છો? સોર્સ. પછી અને એ સોર્સ જે છે સાઉન્ડ છે એ વોલથી રિફ્લેક્ટ થઈને પાછો તમને જ સંભળાય, તો હવે તમે શું થઈ ગયા? લિસ્નર. આવી જ રીતના આમાં છે કે ઇન ધ ફર્સ્ટ કેસ સોનાર ઇઝ અ સોર્સ, ઇન સેકન્ડ કેસ સોનાર ઇઝ અ લિસ્નર. ચલો, સો આમાં શોર્ટકટ એ છે સ્ટુડન્ટ્સ, પહેલાં આપણે કેસ 1નું આન્સર લઈએ. કેસ 2 છે આમાં, પહેલાં બે કેસ આવશે. કેસ નાવ વી ડિસ્કસ કેસ 1. So in a case 1, so students, in a case 1, see, so in a case 1, sonar is a source, enemy submarine is a listener. So FL, here suppose FL dash, so V plus VL what is the speed of sound? 1450. What is the speed of listener? Enemy submarine is listener. And why we take positive? Because it is moving from L to S, so that's why we take positive. What is the frequency of source? That is 40 kilohertz. So 1550 upon 140 into 40. So what is the answer? What is the answer? 42 point. So now students, this frequency is what? Heard by a enemy submarine. Now enemy submarine reflect the sound. Now enemy submarine reflect the sound. So now enemy submarine becomes source. Now the enemy submarines reflect the, so now enemy submarine now enemy submarine becomes source. Okay, now enemy submarine becomes source, and now what is the listener? Sonar become listener. Okay, so students, see, sonar submarine is stationary. So now sonar submarine is stationary, so speed of listener is 0, because now what is the listener? Sonar. બટ સોનાર સ્પીડ ઓફ જે સોનાર જે સબમરીનમાં છે એ તો સ્ટેશનરી છે, તો એ 0. મૂવ કોણ થાય છે? એનિમી સબમરીન, એન્ડ એનિમી સબમરીન મૂવ્સ ટુ ધ વોટ? સોનાર સબમરીન. સો this is the enemy submarine, and what is its speed? Now its speed is what? -100. Why -100? Because now it moved from S to L. બંને કેસ ઈ જ છે સ્ટુડન્ટ્સ, ખાલી આપણે રિપ્રેઝન્ટેશન અલગ કર્યું છે. સો ઇન ધ સેકન્ડ કેસ enemy submarine is source and sonar is listener. But now sonar submarine is stationary, so its speed is 0. Enemy submarine is moving towards, એ તો આપણે ક્વેશ્ચનમાં દીધું છે, enemy submarine is moving towards sonar submarine. So enemy submarine is moving toward sonar submarine. But now enemy submarine reflect the sound, so enemy submarine becomes source. And what is the speed? -100. Why -100? Because now it is moving from S to L. Okay, content માં કંઈ ચેન્જ નહીં કરવાનો. Now what is our final answer? One 450. What is the speed of listener now? And what is the listener now? Sonar submarine. So 1450. What is the speed of source? What is the speed of submarine? -100. And how much frequency is reflect? કેટલી એને ડિટેક્ટ કરી? 42.758. એટલી એ રિફ્લેક્ટ કરશે. So 42.758. So 1450 1350 into 42.758. So what is the final answer? 45.92. What is the final answer? 45.92 kilohertz. Okay, so that much frequency is reflected. ચલો, સો સ્ટુડન્ટ્સ આમાં શોર્ટકટ એ છે, ક્યારે યુઝ કરશો આ શોર્ટકટ? વેન તમને એવું કહે કે ફાઇન્ડ frequency heard by a man sitting in a car and some like that, where we want to find frequency, reflected frequency. ઓકે, મતલબ ઇકોવાળા સમ હોય, રિફ્લેક્ટેડવાળા સમ હોય, એમાં તમારે શોર્ટકટ કરવાની. શું છે શોર્ટકટ? જો એકચ્યુઅલમાં બંને કેસને આપણે ભેગા કરી દઈએ સ્ટુડન્ટ. જો પહેલા કેસમાં શું છે? મૂવ થાય છે L to S, સ્પીડ તો એ જ છે 100. ફર્સ્ટ કેસમાં L to S, સેકન્ડ કેસમાં S to L. બંને કેસને ભેગા કરીએ. ચલો ડાયરેક્ટ આન્સર. આ મેથડ 2 તમને બહુ ઇઝી લાગશે. V plus VL, V plus VS into FS. V plus VL upon V plus VS into FS. Now what is the speed of sound? 1450 L2S. See, first is L2S, so we take positive L2S. So first we take positive, जो plus છે, second માં minus છે, second S2L. So 1450 minus 100, and what is the original frequency that transmitted? 40 kilohertz. So 1550 1350 into 40. Chalo, so now what is the answer, students? See, 1550 into 40 divided by 1350. So what is the final answer? 45.92. kilohertz, 45.92 kilohertz. Okay, so clear students? So easy થઈ ગયું. What we do, we combine both the cases. In first case L2S, in second case S2L. So we combine both the cases in numerator plus 100, in denominator minus 100. Okay, so this method is used when we want to find frequency again reflected by the source. પાછી સોર્સને કેટલી ફ્રીક્વન્સી સંભળાય ત્યારે આવા સમ, મતલબ ઇકો હોય, રિફ્લેક્ટેડ હોય. બરાબર? ચલો તો હજી એક આવો ક્વેશ્ચન જોઈએ. Now see one question. A car sound its horn 48 car sounding its horn of a frequency 48 hertz. Chalo, so this is the car. So now car is source, and what is the frequency of source? 480 hertz. Chalo. Then what moves towards the high wall at a speed of 20 meter per second. Chalo. So this is the high wall, moves towards the high wall. What is the speed of source? 20 meter per second. If the speed of the sound is 340 meter per second, what is the speed of sound? 340 meter per second. Find the frequency of the reflected sound heard by the man sitting in the car. Find frequency of reflected sound heard by a man find frequency of reflected sound heard by a man sitting in a car. Chalo, find frequency of reflected sound heard by a man sitting in a car. So students, again see, this is the same case. First, car is a source that emit the frequency. Now this frequency is moving towards wall, so wall is listener. Now after that, wall is reflect the frequency back, so wall becomes source, and that frequency is heard by a man inside the car. So now that man becomes listener. So students, this is the some type of question our previous check કર્યો. Source, when sound is reflected by the listener, then sound is reflected by the wall, so that source becomes listener. તો પાછું સોર્સ becomes listener થઈ જાય એટલે આપણી શોર્ટકટ ચાલશે. રિફ્લેક્ટ થાય એટલે આપણી શોર્ટકટ ચાલે. શું હતી? બાકી તમારે 2 સ્ટેપ કરવા પડે સ્ટુડન્ટ્સ, પણ હવે એક જ સ્ટેપમાં કરશું આપણે. બરાબર? પહેલાં શું થાય? L2S, S2L બંને સાથે જ લઈ લઈએ. તો શું આવશે? સ્પીડ ઓફ સાઉન્ડ 340. So 340 plus 20, what is the speed of car? Plus 20, first L2S in numerator plus 20, in denominator minus 20. So 340 minus 20. What is frequency of source? 480. So 360 by 320 upon 480. So it is cancelled by 8 into 16 into 2, 32, and 16 into 3. So 180 into 3, so 540 hertz. So that is the frequency. This is the reflected frequency heard by a man sitting in a car. Okay students, બાકી તમે એવું હોય તો આમાં 2 કેસ લઈને કહેજો. તમે કરજો 2 કેસ. ઇન અ ફર્સ્ટ કેસ મેન ઇઝ અ સોર્સ, in a and wall is a stationary. Okay, and what is that speed? પહેલા તમારે -20 લેવાનું છે because it is moving from S to L. In second case wall is source and car is listener. So try કરજો, but બે કેસમાં સેમ જ આન્સર આવશે, બરાબર. But second method is very easy. Upper plus minus and then multiply by original frequency. ચલો નાવ સ્ટુડન્ટ સેમ આવો ક્વેશ્ચન એક એક્સરસાઇઝમાં છે, તમારે ટ્રાય કરવાની છે. દેટ ઇઝ ક્વેશ્ચન 27. ઓકે, આવો જ છે રિફ્લેક્ટેડ સાઉન્ડવાળો ક્વેશ્ચન 27 એક્સરસાઇઝમાં છે. લાસ્ટ ક્વેશ્ચન 27 કેના જેવો છે? રિફ્લેક્ટેડ સાઉન્ડ. ચલો નાવ વી ડિસ્કસ સ્ટુડન્ટ્સ, વી ડિસ્કસ બીટ્સ. Chalo, now students, how the beats are produced? Okay, in the case of beats, when two waves of a slightly different frequency of nearly equal frequencies traveling with the same speed in same direction superposed on each other and produce beats. So what is the beats? When two waves of nearly equal frequency traveling with the same speed in the same direction, and due to that superposed beats are produced. બીટ્સ શું હોય સ્ટુડન્ટ્સ? જો તમને એક્ઝામ્પલ આપું, કદાચ તમને ઓબ્ઝર્વ કર્યું હોય. સી ઇન ધ મ્યુઝિક ઇન્સ્ટ્રુમેન્ટ જે છે પિયાનો, એમાં 2 કીઝ હોય, વ્હાઇટ અને બ્લેક કીઝ. તમે બંને કીને પ્રેસ કરો ને તો તમને સાઉન્ડ ડિફરન્ટ પ્રોડ્યુસ થાય, મતલબ બહુ ન હોય. સો દે સાઉન્ડ હેવ અ ડિફરન્ટ ફ્રીક્વન્સી. દેન વેન દે આર સુપર ઇમ્પોઝ, શું પ્રોડ્યુસ થાય? બીટ. એટલે એ જે સાઉન્ડ પ્રોડ્યુસ થશે ને એની કોઈ વાર એમ્પ્લિટ્યુડ વધારે સંભળાય, કોઈ વાર ઓછું સંભળાય, એવું તમને સાઉન્ડ પ્રોડ્યુસ થાય. તમે જોજો એનાથી શું થાય, એવો સાઉન્ડ પ્રોડ્યુસ થાય બીટ્સ કે જે શું થાય, તેની ફ્રીક્વન્સી પ્લસ ઓર માઇનસમાં ચેન્જ થતી હોય. high thigh, low thigh, high thigh, low thigh. So that are known as beats. Okay. પછી જો કોઈ ગિટાર હોય, ગિટાર વગાડતા હોય તો એમાં પણ શું થાય કે એમાં જે સ્ટ્રિંગ હોય ને એ શું કરશે, એના સ્ટ્રિંગને ટાઈટ કરશે, લૂઝ કરશે, એનાથી બી શું થશે, જે વેવ્સ આવશે એની ફ્રીક્વન્સી સ્લાઇટલી ડિફરન્ટ થાય. when they superimpose, beats are produced. So beatsમાં શું થતું હશે સ્ટુડન્ટ્સ, that superposition due to the two waves, એટલે જે રિઝલ્ટન્ટ વેવ આવે એની ફ્રીક્વન્સી કન્ટિન્યુઅસલી ચેન્જ થાય. So see students, now what is the formula of beats? Suppose there are the two tuning fork. This is the first tuning fork. This is the first tuning fork and this is the one. Second tuning fork. What is the frequency of this tuning fork? A. What is the what is the frequency of second tuning fork? Is nu B. Okay. So number of beats in 1 second. Number of beats in 1 second. Number of beats in a 1 second is given by nu A minus nu B or nu B minus, मतलब A વધારે હોય, frequency of A is high, then nu A minus nu B. If frequency of B is high, then nu B minus nu A. Okay, and see students, what is the another thing is, suppose frequency of A is 20 hertz and suppose frequency of B is 15 hertz, then what are the number of beats in 1 second? So number of beats is what? 20 minus 15. So what are the number of beats? 5. So it means students 5 times amplitude become maximum and minimum. Okay, that is the beats. એટલે શું થાય, તમને એક સાઉન્ડ સાંભળવાની મજા આવે, કેમ કે એમાં શું થાય, હાઈ આવે, લો આવે, હાઈ આવે, લો આવે, એવું કન્ટિન્યુઅસલી ચેન્જ થતું છે. સો દેટ આર ધ નંબર ઓફ બીટ્સ. સો દેટ ઇઝ 5. ઇટ મીન્સ 5 times amplitude become maximum and minimum. Okay. So nu A minus nu B times amplitude become max or min. Okay students, so that are the beats. So in the case of beats, two waves of same frequency of equal slightly nearly equal frequency, थोड़ी अलग होय, and when they are superimposed in the same direction with the same speed, then beats are produced. मैं તમને example આપ્યું એનું, પિયાનો છે, white black keys હોય. So એમાં slightly the sound bar આવે એ slightly differ હોય. So when they superimpose, then beats are produced. Okay, અને બેના superimpose જે sound produce થાય એનું શું થશે, amplitude become maximum, minimum, maximum, minimum. So they are the beats. So see, they are the two tuning fork. What is the frequency of first? Nu A. What is the frequency of second? Nu B. So what are the number of beats in a 1 second? Nu A minus nu B. Chalo, so now see one example students. Two waves of length two waves of length 50 centimeter and 51 centimeter produced produce 12 beats per second. Velocity of sound is. We want to find velocity of sound, and options are 340 meter per second, 331 meter per second, 306 meter per second, and 360 meter per second. The two waves of length 50 centimeter and 51 centimeter produce 12 beats per second. We want to find velocity of sound. Okay, so two waves of length 51 and 50 centimeter produce 12 beats per second. We want to find velocity of sound. So how to find? See, what is the formula of beats? nu1 minus nu2, and how many number of beats in 1 second? 12. So 12 is equals to nu1 minus nu2, but we want to find velocity, and here wavelength, two waves of length. So wavelength are given. What are the wavelength? 50 centimeter and 51 centimeters. So see students, now we want to find wavelength. So what is the speed of sound? What is the speed of sound? Frequency into lambda, nu into lambda. Nu is the frequency and lambda is the wavelength. So what is the frequency? V by lambda. So V by lambda 1, V by lambda 2, V common, chalo, we want to find V. What is lambda 1? 50, lambda 2 51. Now take LCM. So 51 minus 50, 51 minus 50, so 1. So what is the speed? 12 into 50 into 51. So 12 into 5, 6. So 12 into 50, 1600. So what is the speed? 51 into 6. So 306. 306. See, wavelength is in centimeter. Wavelength is in centimeter. So what is our answer? Centimeter per second. So convert into meter. So 306 meter per second. Okay, what is our answer? 306 meter per second. Now see students, some important points. First important point is if wax, if tuning fork is loaded with the wax, then its frequency is increased. Is loaded with the, now when students, if tuning fork When a vex is applied on a tuning fork, then frequency is what? Decreased. Vex means some type of load, okay? So if vex is applied, means some type of load on tuning fork, then frequency is decreased. Okay, if vex is applied on a tuning fork, then frequency is decreased. Why? Because see students, what is the speed of sound wave? E by rho, coefficient of elastic. And what is the meaning by what is the meaning by density? Mass by volume. What is the meaning by density? Mass by volume. So see, it is inversely proportional to mass. When we load it, then mass increase. So now speed is equals to nu lambda. So see, they are inversely proportional. So mass increased, so frequency decreased. So when we applied vex on the tuning fork, then vex means some type of load, then frequency is decreased. When tuning fork is filing, then frequency is increased. Okay, filing એટલે એને સાફ કરવું, sharp. Okay, so when tuning fork is filing, means sharpness is increased, then frequency is increased. And when tension in string is increased, when tension in string is increased, then frequency is also increased. Okay, why? Because what is the speed of wave on a string? T by mu. What is speed? Nu lambda. So see, frequency tension increased, frequency increased. Okay, so if tension on a string is increased, frequency of sound wave is increased. If tuning fork is filing, means if we increase the sharpness, then also frequency is increased. So same ways, if tension is decreased, then frequency is decreased, right? If tension increased, frequency increased. Here it is a proof. And same ways, if frequency tension decreased, then frequency is decreased. And when we apply the vex on the tuning fork, vex means what, student? Vex is some type of load. Vex is what? Some type of load. So when load is increased, frequency is decreased. So now students, there are the two tuning fork. A tuning fork A produce 4 beats with the tuning fork B of a frequency. So now there are the two tuning forks, and what are the number of beats? 4 beats. What is the frequency of tuning fork B? 256 Hertz. When A is filed, are found now A is filed. chalo now tuning fork A is filed. Find frequency of tuning fork A. Find frequency of tuning fork A. So chalo students, so we have a two option. Either we write nu A minus nu B, means number of bits. How many number of bits are there? 4. And one option is what? Nu B. બંને option લઈ લેવાના તમારે. Okay, nu A minus nu B means nu A is frequency of tuning fork A, nu B is a frequency of tuning fork B. What is nu A that we want to find? What is nu B? 256. So what is the answer? 260 hertz. Sorry, what is the frequency of tuning fork B? 256. So what is the answer? 252 hertz. Now see students, here A is filed. So A is filed students, A is filing, means sharpness increased, so frequency increased. So frequency increased, so if we take 252, then that is what the less than 256, but frequency increase થાય છે તો તમારો આન્સર 256 વધારે, 256 કરતાં વધારે એટલે શું લેવાનું તમારે? 260. Okay, why we select 260? Because when A is filing, its frequency is increased, so frequency is more than 256. So we select 260 hertz answer.